Section 12.2, Protecting APIs with Spring Security and OAuth2, imperative. When a user accesses the Polar Bookshop application, Edge service initiates the OpenID Connect authentication flow through Keycloak and ultimately receives an access token granting it access to downstream services on behalf of that user. In this section and the next one, you'll see how to secure catalog service and order service by requiring a valid access token to access their protected endpoints. In the OAuth2 authorization framework, they play the role of OAuth2 resource servers, the applications hosting protected data that a user can access through a third party, Edge service in our example. OAuth2 resource servers don't deal with user authentication. They receive an access token in the authorization header of each HTTP request, then they verify the signature and authorize the request according to the content of the token. We have already configured Edge service to send over an access token when routing a request downstream. Now you'll see how to use that token on the receiver side. This section will guide you through securing catalog service, built on the imperative Spring stack. The next section will show you how to achieve the same result in order service, built on the reactive Spring stack. Section 12.2.1, Securing Spring Boot as an OAuth2 resource server. The first step in securing a Spring Boot application leveraging OAuth2 is to add a dependency on the dedicated Spring Boot starter that includes Spring Security and OAuth2 support for resource servers. In the Catalog Service project, Catalog Service, open the build.gradle file and add the new dependency. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 12.6, Adding dependency for Spring Security OAuth2 resource server.
Next, let's configure the integration between Spring Security and Keycloak. Configuring the integration between Spring Security and Keycloak. Spring Security supports protecting endpoints using two data formats for the access token, JWT and opaque tokens. We'll work with access tokens defined as JWTs, similar to what we did for ID tokens. With access tokens, Keycloak grants Edge service access to downstream applications on behalf of the user. When the access token is a JWT, we can also include relevant information as claims about the authenticated user and propagate this context to catalog service and order service with ease. In contrast, opaque tokens would require the application downstream to contact Keycloak every time to fetch the information associated with the token. Configuring Spring Security to integrate with Keycloak as an OAuth2 resource server is more straightforward than the OAuth2 client scenario. When working with JWTs, the application will contact Keycloak mainly to fetch the public keys necessary to verify the token's signature. Using the issuer URY property, similar to what we did for Edge service, we'll let the application auto-discover the Keycloak endpoint where it can find the public keys. The default behavior is for the application to fetch the public keys lazily upon the first received HTTP request, rather than at startup, both for performance and coupling reasons. You don't need Keycloak up and running when starting the application. OAuth2. Authorization servers provide their public keys using the JSON Web Key, JWK, format. The collection of public keys is called a JWK set. The endpoint where Keycloak exposes its public keys is called the JWK set URI. Spring Security will automatically rotate the public keys whenever Keycloak makes new ones available. For each incoming request containing an access token in the authorization header, Spring Security will automatically validate the token's signature using the public keys provided by Keycloak and decode its claims via a JWT decoder object, which is auto-configured behind the scenes. In the Catalog Service project, Catalog Service, open the application.yml file and add the following configuration.
Listing 12.7, Configuring catalog service as an OAuth2 resource server.
Note: explaining the cryptographic algorithm used to sign the access token is out of scope for this book. If you'd like to learn more about cryptography, you might want to look up Real-World Cryptography by David Wong, Manning, 2021. The integration between Catalog Service and Keycloak is now established. Next, you'll define some basic security policies to protect the application endpoints. Defining security policies for JWT authentication. For the Catalog Service application, we want to enforce the following security policies. GET requests to fetch books should be allowed without authentication. All other requests should require authentication. The application should be configured as an OAuth2 resource server and use JWT authentication. The flow for handling JWT authentication should be stateless. Let's expand on the last policy. Edge service triggers the user authentication flow and leverages the web session to store data like ID tokens and access tokens that would otherwise get lost at the end of each HTTP request, forcing a user to authenticate at each request. To make it possible for the application to scale, we use Spring Session to store the web session data in Redis and keep the application stateless. Unlike Edge service, Catalog service only needs an access token to authenticate a request. Since the token is always provided in each HTTP request to a protected endpoint, Catalog service doesn't need to store any data between requests. We call this strategy stateless authentication or token-based authentication. We use JWTs as access tokens, so we can also refer to it as JWT authentication. Now on to the code. In the Catalog Service project, create a new security config class in the com.polarbookshop.catalogservice.config package. Similar to what we did for Edge service, we can use the DSL provided by HTTP Security to build a security filter chain configured with the required security policies.
Listing 12.8. Configuring security policies and JWT authentication.
Let's check if it works. First, the Polar UI, Keycloak, Redis, and PostgreSQL containers should be started. Open a terminal window, navigate to the folder where you keep your Docker Compose configuration, Polar deployment/Docker, and run the following.
See this code?
Then run both Edge service and Catalog service, /gradle boot run from each project. Finally, open a browser window and go to localhost 9000. Ensure you can see the list of books in the catalog without being authenticated, but not add, update, or delete them. Then log in as Isabel password. She is an employee of the bookshop, so she should be allowed to modify the books in the catalog. Next, log in as Bjorn password. He is a customer, so he shouldn't be able to change anything in the catalog. Under the hood, the Angular application fetches the user roles from the /user endpoint exposed by Edge service and uses them to block pieces of functionality. That improves the user experience, but it's not secure. The actual endpoints exposed by Catalog service don't take roles into account. We need to enforce role-based authorization. That's the topic of the next section. Section 12.2.2. Role-based access control with Spring Security and JWT. So far, when talking about authorization, we referred to granting an OAuth2 client, Edge service, access to an OAuth2 resource server, like Catalog service, on behalf of the user. Now we'll move from application authorization to user authorization. What can an authenticated user do in the system? Spring Security associates each authenticated user with a list of granted authority objects that model the authorities the user has been granted. Granted authorities can be used to represent fine-grained permissions, roles, or even scopes, and come from different sources depending on the authentication strategy. The authorities are available through the authentication object, representing the authenticated user, and stored in the security context. Since Catalog service is configured as an OAuth2 resource server and uses JWT authentication, Spring Security extracts the list of scopes from the scopes claim of the access token and uses them as granted authorities for the given user automatically. Each granted authority object built in this way will be named with the scope underscore prefix and the scope value. The default behavior is acceptable in many scenarios where scopes are used to model permissions, but it doesn't fit our case where we rely on user roles to know which privileges each user has. We want to set up a role-based access control, RBAC, strategy using the user roles provided in the roles claim of the access token, see Figure 12.6. In this section, I'll show you how to define a custom converter for the access token to build a list of granted authority objects using the values in the roles claim and the role underscore prefix. Then we'll use those authorities to define authorization rules for the endpoints of Catalog service.
Figure 12.6. How the user roles listed in the access token, JWT, are converted into granted authority objects used by Spring Security for RBAC.
Note: you might be wondering why we're using the scope underscore or role underscore prefix. Since granted authorities can be used to represent different items, roles, scopes, permissions, Spring Security uses prefixes to group them. We'll rely on this default naming convention for the Polar Bookshop example, but it's possible to use different prefixes or even no prefixes at all. For more information, refer to the Spring Security documentation. See this link. Extracting user roles from the access token. Spring Security provides a JWT authentication converter class we can use to define a custom strategy to extract information from a JWT. In our case, the JWT is an access token, and we want to configure how to build granted authority objects from the values in the roles claim. In the Catalog Service project, Catalog Service, open the Security Config class and define a new JWT authentication converter bean.
Listing 12.9. Mapping the roles from the JWT to granted authorities.
With this bean in place, Spring Security will associate a list of granted authority objects with each authenticated user, and we can use them to define authorization policies. Defining authorization policies based on user roles. The catalog service endpoints should be protected according to the following policies. All GET requests sent to the //books or /books/ISBN endpoints should be allowed, even without authentication. Any other request should require both user authentication and the employee role. Spring Security provides an expression-based DSL for defining authorization policies. The most generic one is has authority, role_employee, which you can use to check for any type of authority. In our case, authorities are roles, so we can use the most descriptive has role, employee, and drop the prefix, which is added by Spring Security under the hood.
Listing 12.10. Applying RBAC to limit write access to users with the employee role.
Now you can rebuild and run catalog service /gradle boot run and go through the same flows as before. This time catalog service will ensure that only the bookshop employees are allowed to add, update, and delete books. Finally, stop the running applications, Control-C, and containers, Docker Compose down. Note: to learn more about the authorization architecture in Spring Security and the different strategies available for access control, you can refer to Chapters 7 and 8 in Spring Security in Action by Laurentiu Spilka, Manning 2020, where they are explained in great detail. Next, I'll guide you through some techniques for testing security in an imperative Spring Boot application configured as an OAuth2 resource server. Section 12.2.3. Testing OAuth2 with Spring Security and test containers. When it comes to security, writing autotests is usually challenging. Fortunately, Spring Security provides us with convenient utilities to verify the security setup in slice tests. This section will show you how to write slice tests for the web slice using mock access tokens and full integration tests relying on an actual Keycloak container run via test containers. Before starting, we need to add new dependencies on Spring Security Test and Test Containers Keycloak. Open the build.gradle file for the Catalog Service project, Catalog Service, and update it as follows. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 12.11. Adding dependencies to test Spring Security and Keycloak.
Testing secured REST controllers with Web MVC Test and Spring Security. First, let's update the Book Controller MVC Test class to cover the new scenarios, depending on the user authentication and authorization. For example, we could write test cases for delete operations in these situations. The user is authenticated and has the employee role. The user is authenticated but doesn't have the employee role. The user is not authenticated. Delete operations are only allowed to the bookshop employees, so only the first request will return a successful answer. As part of the OAuth2 access token validation, Spring Security relies on the public keys provided by Keycloak to verify the JWT signature. Internally, the framework configures a JWT decoder bean to decode and verify a JWT using those keys. In the context of a web slice test, we can provide a mock JWT decoder bean so that Spring Security skips the interaction with Keycloak, which we'll validate later in a full integration test.
Listing 12.12. Verifying security policies at the web layer with slice tests.
Open a terminal window, navigate to the Catalog Service root folder, and run the newly added tests as follows.
See this code?
Feel free to add more WebSlice auto tests to cover GET, POST, and PUT requests. For inspiration, you can refer to the source code accompanying the book, Chapter 12/12 End Catalog Service. Integration tests with Spring Boot Test, Spring Security, and test containers. The integration tests we wrote in the previous chapters will not work anymore for two reasons. First, all POST, PUT, and delete requests will fail because we are not providing any valid OAuth2 access token. Even if we were, there is no key cloak up and running, required by Spring Security to fetch the public keys used to validate the access tokens. You can verify the failure by running the following command from the Catalog Service root folder.
See this code?
We have already seen how to use test containers to write integration tests against data services like a PostgreSQL database, making our tests more reliable and ensuring environment parity. In this section, we'll do the same for Keycloak. Let's start by configuring a Keycloak container via test containers. Open the Catalog Service Application Test class and add the following setup.
Listing 12.13. Setup for a Keycloak test container.
The Keycloak test container is initialized via a configuration file I included in the code repository accompanying this book, Chapter 12/12n/catalog service/src/test/resources/test-realm-config.json. Go ahead and copy it over to the src/test/resources folder of your catalog service project, Catalog Service. In production, we would call Catalog Service via Edge Service, which is responsible for authenticating users and relaying access tokens to the downstream applications. We now want to test Catalog Service in isolation and verify different authorization scenarios. Therefore, we need to generate some access tokens first, so that we can use them to call the Catalog Service endpoints under testing. The Keycloak configuration I provided in the JSON file includes the definition of a test client, Polar Test, that we can use to authenticate users via a username and password directly instead of going through the browser-based flow we implemented in Edge Service. In OAuth2, such a flow is called a password grant, and it's not recommended for production use. In the following section, we'll use it just for testing purposes. Let's set up Catalog Service application tests to authenticate with Keycloak as Isabel and Bjorn, so that we can obtain the access tokens we need to call the Catalog Service's protected endpoints. Keep in mind that Isabel is both a customer and employee, whereas Bjorn is only a customer.
Listing 12.14. Setup for obtaining test access tokens.
Finally, we can update the test cases in Catalog Service application tests to cover several authentication and authorization scenarios. For example, we could write test cases for post operations in these situations. The user is authenticated and has the employee role, extending the existing test case. The user is authenticated but doesn't have the employee role, new test case. The user is not authenticated, new test case. Note: in the context of an OAuth2 resource server, authentication means token authentication. In this case, it happens by providing an access token in the authorization header of each HTTP request. Create operations are only allowed to the bookshop employees, so only the first request will return a successful answer.
Listing 12.15. Verifying security scenarios in integration tests.
Open a terminal window, navigate to the Catalog Service root folder, and run the newly added tests as follows.
See this code?
There are still tests failing. Go ahead and update them by including the right access token, Isabel's or Bjorn's, in any post, put, or delete request, as you learned in the previous example. When you're done, rerun the tests and verify that they are all successful. For inspiration, you can refer to the source code accompanying this book, Chapter 12/12n/catalog service,